Hello and welcome. So in this video I'm going to explain you the process of forming a quadratic function from the real world scenario using the information that is available to us. For example, the time taken and the distance covered and the time and the height of a flight of a rocket or anything that you threw it up in the air and you got the data and as it is going upwards reaching a maximum height and again it will come down to the ground. So during this process at different times whatever is the height that is attained it will take, and we just use that information and put it in a graphic calculator or any online resource that you have like a Desmos or any graphic calculator utility, and you will come up with a regular quadratic function. So it is nothing extraordinary. I see students confused with what is a domain, what is a range, what is this increasing interval, decreasing interval, X intercept, Y intercept. Everything is connected to the real world scenario. Okay, now for example, I have a tennis ball here. I'll throw it up in the air. Let us say I just throw it up into the air and it reached to a maximum height of some feet, 10, 15 feet, and then it came down. Everything won't happen in 1 second. So at different intervals of time, let us say from the time it is released from your hand, in 1 second it went up to this height, 2 seconds, 3 seconds, like that. At different points of interval of the time, you will note down the height. Let us say we have that mechanism, a big tape or some you utilize the resources available to you and you found the height of this tennis ball at a different time intervals. And I have a sample data for you. I'll use the data, I'll write the numbers here, and then from that data we are going to put it on the graph, which we'll call it as a scatter plot, and from the scatter plot you are going to get the quadratic function. And once you have a quadratic function, from there I'll take you through, like walk you through the what is the domain, range, etc. All right, these are my numbers. I have the sample. Let us say further this is the time and this is the height. Time is taken in seconds and the height in feet. 4, 5, 6, 7. All right. 0, 1, 2, 3, 4, 5, 6, 7. And the height, let us say your height initially it was 5 feet. In 1 second it reached to a height of 8 feet, and in 2 seconds it reached 11, 3 seconds 13, then in 4 seconds, see from 13 it is falling down, coming down, so 12 feet, and in 5 seconds became 10, then 6 and 0. That is in 7 seconds it reached the ground level. So this is the data we got. These numbers we ourselves came up with. So it's clear, right? I used a tennis ball, threw it up in the air, and these are the items I got. In 0 seconds, started from 5, it went up to so and so height, and this is the information I have. So what do you do from here? I'll take this info and try to put it on my graph. Okay, and I already have drawn x and y axis for you, and it is calibrated, so maximum 7 I need. I'll write here, this is 0, 1, 2, 3, 4, 5, 6, 7. And the height is 13 max. 1, 2, 3, 4. Okay, this is 2, 4, 6, 8, 10, 12, and this is 13, and higher you can go. So this is what you have. Now, I have my x-axis, y-axis. According to this information, I calibrated. So according to the space that is available to you on your graph sheet, you can calibrate. You just need 7 units down, 7, or you can add just 1 or 2 extra there, right? And then height max 13 I need. I went up to 13. Little more extra space also I might need for my actual graph. Okay, so then I'll take each point. This is my x and y value. When x is equal to 0, what is the value of y? When x is 0, y is equal to 5. So for x value 0, this is x 0, and the y value is 5. 0, 2, 4, 6, so 5 is here. I got my 1 point there, 0, 5. And even you can write 0, 5. Then you have 1 and 8. When x is equal to 1, for x is equal to 1, y goes to 8. Okay. Then take x is equal to, this is 1, 8. For x is equal to 2, y goes to 11. 2 and 11. This is my 2 and 11. This is 11, 10, 11 is somewhere here. Let me see. Yeah. 2 and 11. Then 3, 13. For x is equal to 3, 13, somewhere there. Now take 4 goes to 12. X 4, y 12. 4 to 12. Right. Then 5, 10. 5 goes to 10. 10 is here. 5 is there. 5, 10. 6, 6. 6 and 6. Yep. And 7, 0. 7 goes to 0. So those are my points. And for convenience, we will even write them down. 0, 1, 1, 8, 2, 11, 3, 13, 4, how much? 12, 4, 12, okay. 5, 10, yes. 6, 6, 7, 0. So this is the information we had, our numbers we have. We measured the height at this intervals of time in 1 second, 2 second, etc. All that you have now. Okay, so these x values are here in this scenario, the time. This time, that is the input value we say. First, for this particular time, that is the height. So that's why this initial values, which you can also call them as input, and those are the output values. So the first values, these values that we put in on the x-axis, or those initial values, those input values, you can call them as domains. And here, the domain, and it is what is the domain in this scenario? It is nothing but time in seconds. That is there on the x-axis. Now on the y-axis, you are having the height. It is the height in feet. Okay. And these values that you have taken on the y-axis, as this is the domain, the word connected to domain with reference to the y-axis is the range. Let me call it as range All right. So I have a domain and I have range. And as I get a function and about the values, the restrictions, I will talk to you in a minute. And you already know that in this scenario, we are talking about the time. So when you talk about time, can you go backwards in the time? That is, there is no way you can go to a negative time. So that's why we don't have the negative x-axis. Similarly, the height is always positive. Starts from 0, go all the way up. You don't go down to the height. So that's why height is also not negative. We take only the positive values for this domain and range in this particular scenario where you are talking about the time and the height. Similarly, you have to judge whether you take any negative values and all. And sometimes in the functions, they talk about the real numbers. Domain is the whole of the real numbers, means everything on the left side also considered. Then you have to take everything from negative infinity to positive infinity. Similarly, the height, that also they say it is the set of real numbers. So not only the positive and negative. So go by the given situation. If you are in this real world scenario, you know that domain is the time or it is the horizontal distance, something like that. It has some limits, like it cannot be negative. You always start from 0 and go on to your right. Similarly, if it is the height or anything that is measurable and it cannot be negative, it should always go upwards. Okay, you got the point now. Now, our question is, let us say, all right, I have this information. I know the height of that tennis ball. After 2 seconds, it was there at 11 feet. And after 3 seconds, it is up there. But we are curious. You want to know what could be the height of this tennis ball in 2.5 seconds. In 2.5 seconds, or just before falling down at 6.7 seconds, where was it? See, there is a lot of gap in this. So likewise, we would like to know the whole flight of the tennis ball from the time it released from your hand to the time it reached the ground. You want to know exactly what could be its height in between. See, the time, it is a continuous process, right? Continuous. After 1, directly you won't go to 2 seconds. 1, 1.5, 1.2, like that it is. So you want to look at the height of the tennis ball at different points, like not only at this distinct 1, 2, 3, in between 1.5 or 1.6. So in order to do that, that's where you have something called as a neat graphic calculator is there. By using this graphic calculator and quadratic regression, you can come up with nice quadratic function. And that function will give you everything, what all you are looking for, right? And not only this, online you have Desmos, GeoGebra, and such a software you can utilize and get this function. So I already used that software, and I'm going to show it to you in a separate video just to get that quadratic function. But here, let me directly put in the function and tell you how it looks like. So this is what I have here, 0.83. So from this, only these numbers I substituted, I put it in the, or I supplied to the software. When I gave it to the calculator and or that online utility, I got this neat function which says f of x is equal to negative 0.83 x squared. This is the function. So using that graphic utility, you came up with the function f of x is equal to negative 0.83 x square plus 5.21 x plus 4.38. So this is the function. What if I have given you this function and asked you to find, first I'll state, okay, this is the function representing the height of a tennis ball for a given time, x seconds. Then what is the maximum height reached? what is the domain, what is the range, X intercept, Y intercept means, definitely you will be lost. You do not know exactly. But now onwards, please remember, this whole thing you just got from that scatter plot. From that data, people came up with different types of functions. So try to connect this function with what we talked already. So let us use this and try to change it off. How? First thing is the time, right? This x is nothing but the time. So I'll just replace this x with a t to make it more friendly to us. And f of x, I'll write it as h of t. That is, it is telling me that the height at whatever time interval, whatever time you have taken that. And x is equal to t, and that is also the time. Okay, so I'll write this as f of x. Now x became what? T. So I'll replace it. It is f of t is equal to negative 0.83 t square plus 5.21 t plus 4.38. Okay. So now the same function f of x, we did not do anything. We didn't change any numbers. Everything is same. Just we try to make it user friendly, and I made a mistake here. It should not be f of t, but this h, please. Sorry, I should have written this h. Let me double check. H of t is equal to 0.83 t square plus 5.21 t plus 4.38. So now this function will give us all the values, that is what all these y values you are getting, or the height with reference to the time, you can get using this function now. But the thing is, the values are not going to be exactly like here 0, 5, 1, 8, 2, 11, but it gives you almost closer values. And using this, like I said, I can even find the height at 1.5, 2.5 and all that. So let me show you those values, how they look like for different time. This is t, h of t, 1, 2, 3, 4, 5, 6, and 8. So if I have for 0 means this t becomes 0. So 0 square, negative 0.83, negative 0.83 times 0 square plus 5.21 times 0 plus 4.38. So what is this? Whole thing, this becomes 0. 0 times anything is 0. This is also 0. 0 plus 0 plus 4.38 is 4.38. So when x is equal to 0, your y is not 5, but it is something like 4.38. Somewhere here you have that point. Similarly, when x is equal to 1. And moreover, remember, whenever you have x is equal to 0, the point will fall on the y-axis, right? And that is what is called as the Y-intercept. To get the Y-intercept, just remove this and that, because of that variable, those x values, those domain values, the 0 and 0, this is gone, just 4.38. That is your Y-intercept, like I showed here. Similarly, for 1, 2, 3, 4, 5, 6, 7, you have those values. Four 4.38, 8.76, 11.48, then it is 12.54, 12.54, 11.94, then for 5, 9.69, 5.76. For 7 it was 0 before, and now you have 0.18. So can you see the slight change in the values? Like even for 0 it's not 5 and it's changing. I'll use blue. Okay. Black. For 1 it is 8.76. 1 goes to 8.76 somewhere here. That's 1. 2 goes to 11.48. 2 is 11.48. That point is there. 3 goes to 12.54. 3 and 12.5. 4 goes to 11.94. Little down. 9.69. 5 and 9.69. Somewhere here. And 6, 5.76. And 7, 0.18. 0.18 means somewhere here. And then I will connect all the points from here. Just it is a U-shaped. You'll get a parabola. All right. So just approximately I'm drawing here. By connecting all these dots, you got a graph. So this graph, what is the advantage of this? Like I was telling you again and again and again, at any point, like when x is equal to 1.5, my height is at this point. If x is equal to 2.5, 3.1, 3.2, for any value of x, you can find what is the y value. Like this, each one of these will tell you about x and y values, or the time and the height. Okay, so from where we started and where we reached, you see this, you got the dots, and from the dots you put it in the calculator, you got a function. Then using these values you got, and even this graph also, you'll get a neat graph using Desmos or using your graphic calculator. All right, now what I'm trying to, where I'm trying to go from here is to show you about the X-intercept and the Y-intercept. I already talked to you about the Y-intercept. When this X coordinate, the time is 0, what you get here, that is the Y-intercept, which is 4.38. Similarly, X-intercept is at this point. When X is equal to, I cannot get it on this direct now, so you have the value using your graphic utility. It is at 7 it was 0.18. At 7 means it should have been here at this point. At 7 it was 0.18. The graph, I should have put it there, and at 7.028, at this one, when x is equal to 7.028, the y value is 0. So that is the X-intercept. That is how much? 7.028 precisely. All right. So this X-intercept over there, this is the Y-intercept you got. And the maximum height is not 13 now. It is slightly less than 13, the height. And on using, again, maximum height means you have to go to the, what? The vertex, the turning point, and all that you can do. So I'll show that in the next video.